Welcome back to leading to a question 2019 B-1. It's an axonometric projection question. The image on the right shows the packet for Doritos tortilla chips, and you can see that graphics there. It is based on a regular hexagonal prism which has been shaped as shown. Okay, so it's kind of a complex shape, but it's all based on regular hexagons. Figure B1 shows the incomplete diametric projection. So diametric, right, two angles are going to be the same, using axonometric axis method is the packet. Okay, so we've got our diametric is going to be there. The plan and elevation are also shown, so we've got our plan and elevation here. Draw the required axonometric axes X, Y and Z and the isosceles triangle. So isosceles because we're going to have two sides the same here. Triangle ABC. So we'll start with that. We're going to have our angle 115 and it's going to be the same angle on this side. So I'll just draw a vertical line to begin with and measure 115. Okay, and our isosceles triangle, so they don't tell us any length for the sides there, but they do tell us that this is 120, so we can give a base length for our ABC, or for our length BC of 120, so that will be 60 left and 60 right. So just going to measure, project down here a little bit, measure 60 left, 60 right. Find my B and C. That's one side of the triangle. And then A is going to be found at 90 degrees. So we can see there's a symbol indicating 90 degrees there for length AC. So 90 degrees to my Z axis. So these sliding set squares for right. Okay, so that is my triangle A, B, C. That's my y-axis, z-axis, and x-axis. Right, so I've completed all of that. Part B, draw the plan and elevation orientated as shown. So always kind of follow the order in which they ask you to do things. So I'm going to start by drawing my plan. Okay, and it's a regular hexagon. So we'll start with this larger one first of all, and we'll find the location of those points. And we know that one side is 40 long for the regular hexagon. So I'll do my setup first of all, I suppose, and then I'll get into the actual plan view. So project down. semicircle. While I'm at it, I'll complete the setup over here. So note that I'm not going at 30 degrees, I'm actually using my set square or using my T-square to project out, actually, just to make that more clear. Slide this back. AC. I'm going perpendicular to that. So I should move that back further. Anywhere out here, check there, bisect this length, and draw my semicircle. Where the semicircle intersects the axis coming out here, the Z axis. It's my vertical plane and my edge of the horizontal plane. Okay, so now I'll go down to drawing my plan. So like we saw there, there was 20 and 40 was the length of one side, so there. There, I'm just going to project those distances down. We'll need them later. Okay, and using our set squares together, okay, it's going to come off the table here. There's my 60 and 45, so that's essentially a 60-degree angle, just that everything's twisted at 45 degrees because of my 45-degree angle there. Okay, and I can repeat that same process I can project out here to look at that. Yeah, so once I've that done, actually need to slide a little bit over. There's actually multiple ways of doing that, because I know I have side length 40, so each side is going to be length 40, so that will actually have found us there and there. So that will actually my completed set square, or my completed regular hexagon. smaller hexagon contained within it, they're saying that it's equal. So distance from there to there is going to be 20, 20, 20, 20, 20. So I'm going to set my compass thread as 20 just so it's uniform. Actually I can set this as 20 here. I should find the center. For each one of those. And hidden detail then to represent that. Okay, so that's my plan view, and now I need my elevation. So looking here, we've got our 20, 40, 20. The height is going to be the height of our plane there, and we've got a height 20 and 20 there. So let's step off our heights first of all. Got 20, 40, 20. Okay, so that's the top and bottom, and then our smaller hexagon there is actually that is a, I suppose, a vertical cut. That's a vertical representation or an edge view of that smaller hexagon, and we know that smaller hexagon is positioned halfway along all of those. So I'm actually going to measure into the center here, 20. Because it'll be positioned there, and yeah, so the distance from there to there would be 10, and there to there 10. So I can actually measure 10 halfway along these as well. So that's going to help us to find those other points that we need. Okay, and then they haven't given us a height there for that. I'm going to assume it's halfway. I'm going to assume it's halfway. Do we have a measurement there? 72, so can bisect that distance. Just a fair bit. My hexagon is going to be positioned there. That's my edge view of it. Okay, so a bit in the setup of this question, but once we've got it done, we should be able to go along. So now I'm just trying to match up my points with what they've given us in the drawing. Extend that on. Right, probably didn't even need to bisect that because when I joined those diagonals that would have found the centre, but that's fine. It's good to be accurate with it. So that's my plan and elevation drawn. Okay, draw the axonometric projection of the portion of the package as given. So they want us to draw this section of the package to begin with, and you can see that surface there represents, so we're essentially drawing those surfaces. So I'm going to project at our required angle, which is lined up with our z-axis. Obviously if you have a adjustable set square, you can use that also to make life a little bit easier. Vertically then, let's do the rectangular surfaces first. There, follow these down. If you want to index them, index all those points, that may also help you. Or if you want to add colour, all of that works. Okay, you just need to find a method that is useful for you. Okay, and finally we want that centre point, which is part of that hexagon, that smaller hexagon, represented here. So I'll project that up onto this line coming down. There we have that. And this should actually line up when I join the diagonals all the way through. Okay, so that's a portion that they have given us. Okay, then part D, complete the remainder of the package in the axonometric projection. So what I am going to do with that is I'm actually going to start with the hexagonal prism at the top and bottom, and then I'll move on to this bit in the centre. Okay, I'll just kind of kind of create something concrete for me to work off of. So quite a few projection lines here. And back lining up my z-axis again. Okay. Once again, if you want to index these, you can, but I'm just going to follow my points. So that is represented by this corresponding point. So project it up, project it across. You extend it on further. There. Follow around, so that's joining back to that corresponding point, joining back to this here, and then here. So this is going to be my top surface of the hexagonal prism. And then we've also got this bottom edge, so I'm starting here, coming across, it's all going to be parallel lines, but let's follow it back anyway. So follow it up, and that's that outside one to there, and that's going to be joining that to there. So let's draw those in. Okay, and now my bottom surface, so that's the edge, this is my next edge, follow up, and there, there. Identical to what we had above it. Okay, so now we want to start joining diagonals, okay, because we know, looking at this, at each one of these flat surfaces, so this here is kind of identical to what we have there, all along one plane, so I can join those, and then after I'll add in my, I'll just add a little colour to, I suppose, explain this a little better. Okay, so I'm going to do that surface next. Okay, which is going to be kind of around here, trying down triangular shape, like that. Okay, so join the diagonals, I'll find those triangles. Okay, and then yeah, you can actually join these diagonals also. And we're not going to see see those ones at the back. Okay, I could just join these, but just to show you, if I project, because these are lines that I'm missing along my middle hexagon, my smaller hexagon, just to show you that they should match up. So that point coming down, if I found that, and it comes down and matches up there. So I'm just going to join those up and here. Okay, and that is close. It doesn't look quite right. It feels like, yeah, if I was looking here, I'm going to see this surface. Okay, so that point projected up corresponds with this one, so I need to actually bring that down. Okay, project up from the plan. So that there. Okay, so that is a line along my hexagon, so that's going to be continuing to there, by my hexagon, and then I need to draw the triangular surfaces that are joining them up. So that's coming from here. Back to here. So it's kind of a really tight angle. Hard to visualize, but draw it up going back and double checking. We're going to see anything on this side we won't, because it's all behind the corner. Yep, so that is that question completed. And if we just want to double check looking at our 3D view to see it's going to help us with any other bits. No, I think that's everything there completed. So that's the 2019 axonometric question. Kind of a tricky one in terms of setting it up and getting the final bits done.